Welcome back. This will be part 3 of similar triangles. And today we're just going to go through the second example of similar triangles. So this says, determine whether the pairs of triangles are similar. In these type of questions, we got to see, well, just like example number 1, prove whether they're similar. In these questions, there may be cases where they're not, and that's fine. We just have to say that they're not and prove that they are not similar. So with this first question, we've got two angles, right? How we're going to approach this question is, well, looking at angle AB, angle ABC, it seems like that this angle right here, this angle A, if I were to do that angle sum of a triangle, right, 180 minus 40 plus 80, it should get me to 60, right? You can double check that on your calculator, right? So what I'm going to say is, well, angle CAB is equal to angle FDE, which equals to 60 degrees, because of the angle sum of triangle, which is 180 degrees. Okay, so I proved that. Now, let's do the exact same thing to prove angle E, right? Same thing. If I say angle DEF, if I use the angle sum of a triangle, let's predict that angle DEF or angle E is equal to 80 degrees. Okay, check that with your calendar, and I presume that that would be right. Is equal to angle ABC, which equals to 80 degrees, because of the angle sum of triangle, which equals to 180 degrees. Okay, we've got those two. If I've already proved two angles are equal to each other, that means, right, hence triangle ABC is similar to triangle DEF based on the test of it satisfying AAA, right? Therefore, the triangles are similar. Okay, we need to have these statements here, whether that is proving if it's congruent or if it's similar. Okay, let's go to question B, right? We've got two sides and one angle. Let's predict that it kind of seems like SAS, right? Let's just predict it and prove whether this hypothesis is right or not. All right, let's deal with the sides, deal whether those two sides are proportional to one another. All right, let's go. Let's do angle BD, right? You can do it whichever way you want to find the proportion, as long as the number or the scale factor is the same. I usually like to do it with the bigger triangle, but let's just try it with it being the smaller triangle first at the top or in the numerator. So BD over EF equals to BC over GF, right? So it in. BD is 4 over 6 equal to 6 over 9, which should get me to 2 over 3 for both fraction, right? So, okay, the sides are proportional. Let's see if the angles are equal, okay? If I look at it, right, the angle in triangle BCD is in between my two sides, so it's an included angle. However, for my triangle EFG, this angle is not in my included angle. My included angle should be here, right? So now what I can actually see is, well, it seems like they're not similar. right? So this is how I'm going to write it. Angle DBC is not, right? If I slash inside the equal sign, that means it's not equal to angle EGF, right? Because angle EGF is not the angle included by the line EF and GF. Yeah, that's how I proved that they're not. We predicted that it would be SAS, but it seems like it's not. Therefore, what I'm going to write down as my final statement is the triangles are not similar. That's it. I'll see you next time. Bye.